Hello and welcome to the guided practice for Number Sense 1. Let's go ahead and get started. Okay, we are going to be writing in two different forms, standard form and scientific notation. First up is standard form. Standard form means normal. We want a normal number, meaning we don't want this x here. We don't want this exponent or times 10. We just want one number. Now in standard form, sometimes that number might be big. It either might be a decimal with many zeros, or it might be a number without decimals and many zeros. How we can tell is by the exponent. Alright, so let's go ahead and do step A. Step A is to rewrite the problem. 6.3 times 10 to the fourth power. Okay, so now this is all about just moving decimals. You're not actually going to be doing any arithmetic, adding, subtracting, multiplying, dividing. It's simple counting is mostly what you need here. So let's take a look at what I mean. Alright, this number right here, it's positive, so that means we're going to go to the right. What do you mean we're going to go to the right? Meaning the decimal is going to go to the right. So for step B, we are going to move that decimal by rewriting just part of the problem, just the number to the left of the times 10 to the fourth power, and moving it, like I already said, 4 times to the right. So 1, bounced over the 3, then we're going to bounce again, that's 2 times, bounce again, 3 times, and bounce again, that's a 4th time. 1, 2, 3, 4. And then we're going to put our decimal in a new slot. This is the new decimal. Okay? Now, all this space down here, we got to fill it in. So let's go ahead and do that. So we bounced around a 3. We bounced around nothing, 0. Nothing, 0. Nothing, 0. So remember, this is gone now. This decimal right there. So our final answer is going to be 63,000. That is the standard form of 6.3 times 10 to the fourth power. Alright, so for number 2, we have this big, long standard notation or standard form number. But now we want to make it into scientific notation. So that means we want to take it back to the kind of problem we saw in number 1 with that times 10 to the something. So here's how we do it. Step A, rewrite the problem. 48 billion. Now in scientific notation, in the first problem again, we had a decimal, we moved it. We're going to do the same thing, except for if you have no decimal, first thing is add 1. I'm going to add 1 right there at the end to the furthest right that you can. Furthest to the right that you can. Then, step B, we're going to move it. We're going to move it right here. So we got all the way to the left. We got this number right here. We want to go as far left as we can without going past the last number, the last number to the left. So let's see how that goes. Bounce 1, bounce 2, bounce 3. I'm bouncing in between digits. Bounce, 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 bounce. Alright, there is the new decimal place right here. This decimal goes away. Alright, so let's go ahead and count the bounces. 1, 2, 3, 4, 5, 6, 7, 8, well, that's an ugly 8, 8, 9, and 10 bounces. Okay, so that means our final answer is, step C is going to be 4 point, because the decimal right there, 8, and then all these zeros, we're just going to ignore them now. Times 10, because we want it in scientific notation. So it's always some decimal times 10. And then for the final power, what goes there? Those bounces we counted, there was 10 bounces. So 10. So that is the answer, 4.8 times 10 to the 10th power. Number 3. Number 3 says write 2.8 times 10 to the negative third power in standard form. Okay, this is like the first problem, except for we see negatives involved. That means instead of moving to the right, we are going to move to the left. Alright, so step A, rewrite the problem. 2.8 times 10 to the third. Again, we got this negative exponent, so we're going to be moving to the left. So for B, we're going to rewrite the problem, but give yourself some space to the left, just like I'm doing here, because we are going to be moving to the left, not to the right. So we want to make sure we leave space over here. Again, we start with the decimal that we're given. We don't need to add one because we've already starting with 1. We're moving to the left because it's a negative exponent, so we're going to bounce this many times to the left. So bounce 1, bounce 2, bounce 3, and put our new decimal in. Boom, right there. Throw in some zeros to the empty slots. And then our final answer is 0.0028. That is the standard form. Negative exponents are often going to look like this. Positive exponents are going to end up with big numbers, like in the millions and billions or thousands or hundreds even. It could be small numbers. But you probably won't, you are unlikely to have decimals left over with positives. Okay, number 4, write 0.0000354 in scientific notation. Alright, you should be getting pretty good at this by now. So step A, rewrite the problem. 0.000, another 0, one more 0, and 3, 5, 4. Okay, that's mostly legible. Then, just like before, we're going to move it. So if we don't have a decimal, we add one. But in this case, we do. We got a decimal right there. And then, whatever digit you have that's furthest to the left. This is just like when you don't have a decimal. Whichever one is furthest to the left, that's not a 0, you want to be just to the right of it. Right there. So let's go ahead and start bouncing. Bounce 1, bounce 2, bounce 3, bounce 4, bounce 5, bounce 6. So we're going to put our new decimal right there. Bam. And then, next step, boop, B. We are going to rewrite our number, 3 point, because see, remember we have the decimal right there, 5, 4 times 10. When you're writing in scientific notation, always times 10 to the how many powers? Let's count them. Bounce 1, bounce 2, bounce 3, bounce 4, bounce 5, bounce 6. So we're going to end up with a 6th power, but because we moved to the right going into scientific notation, we are going to be left with a negative exponent. So when you're going to scientific notation, here's a rule you want to write down your notes. For scientific notation, if you go right with your decimal, you get negative. If you go left with your decimal, then your exponent's positive. That is the rule for the exponents. Okay, thank you very much. Go ahead and get started on the practice problems. Let me know if you have any questions, and you can use your teammates as well.